Hi, I'm Clay Allen. I'm a mechanical engineer, and I'm in my shop. This is where I spend about half my time. I do engineering, design, mostly mechanical, and I do a lot of prototyping. Behind me, you can see this is a CNC lathe right here. CNC lathe, which means it's computer controlled, the motion of the machine and changing the tools. This is a CNC milling machine. It's a 4-axis machine, which means that it can cut 4 simultaneous motions at the same time. This machine is unbelievably accurate. It's actually a 1980s machine, but what's most amazing about this particular machine is that it is as accurate today as it was the day that it was brand new. We'll get to that in a little bit. Start cutting some real parts. That's when it actually gets pretty exciting, is when you start seeing the chips fly. So I mentioned I'm a mechanical engineer. I have a degree in mechanical engineering, and I do a fair amount of engineering, but basically what I do is solve problems. I design mostly, and customers come to me with particular problems that they either can't solve themselves or they don't have the manpower in their own company to do, and I'm essentially a consultant in that respect. A consultant that actually does not only the engineering but the fabrication, and we essentially help companies get their products into production. That's really our area of expertise, whether it's design for manufacturability, DFM, or helping companies get new products off the ground and into production for the first time. We generally only work with corporations. Part of the reason for that is that they have a background and experience in manufacturing, which is not something that you just wake up one day and decide you want to be a manufacturer. It's actually pretty challenging. There are a lot of pitfalls. There are a lot of things to do wrong, and you have to have a good head for business in order to be a manufacturer. Like I said, there's a lot of things that can go wrong. Just about the worst thing that could ever happen is to have an entire shipment of parts show up and have every single one of them be bad. That's going to cost you and the people who helped you make them to correct that problem. And so the goal is to develop a product, manufacture parts that are right when they show up. So we don't do a lot of automotive parts. That's not really our specialty. But when we do, they're pretty exotic, pretty unique. So here's one we just did. So the customer brought us this piece right here. This is off of a 1940s hubcap. And all we got was this piece right here in the hubcap, which I'll show you in a minute. So we also got this sketch, hand-drawn, which is pretty typical. At least it's not on a napkin, it's actually on a piece of paper. So we start with a piece of flat stock, looks like this. We mount it onto a fixture that we designed, like that. Clamp it down. Cut it on the machine, take it out of the machine. Looks like this. So the real challenge in design for manufacturability and machining is how do you hold on to the material? How do you keep it from moving around? Especially when it's in a part like this, you don't have anything to hold on to. I mean, there's really not much here. So the secret of that is fixturing. And if you've ever been in a machine shop, that's not something that you see very often. But in order to do it right, you have to not only be able to figure out how to hold on the material, but you also have to design and build the fixtures to do that. Then we take the material, put it in this custom fixture that we designed just for this project. Clamp it down. So this is the next tool in the tool carousel of the machine, this nasty one right here. It's actually a custom tool. And the machine will cycle that around into the position to where it changes the tool out automatically. finished part. Perfect. It'll require a little bit of polishing, but not very much. Goal is to come off the machine as perfect as you can get it. This is pretty dang good. So this is a semi-finished part. There's still some polishing to do on the crossbar, and there's a little bit of polishing to do on the hubcap, but it's pretty much complete. So this is what we call in the industry art to part. Here's the art, there's the part, and a whole bunch of stuff in between. Alright, all those hours you spent in algebra wondering what the heck you were going to do with that X, Y, Z stuff you were messing around with, and in trig trying to figure out cosine, sine, all that stuff, this is where it actually applies. This is a coordinate system for the machine, and the way it works is that you've got an x-axis, a y-axis, and a z-axis. So here we go. So here's the x-axis, here's the table, moving back and forth in the x direction. Here's the y-axis, that's the other coordinate system. And the z-axis is the spindle. So that's what all that stuff was for. It actually has a value. So the biggest difference between me and any of the other engineers that I've worked with in the past, have any experience with, and I'm also guessing the biggest difference between me and other applicants for the show is I have a tremendous breadth of experience. I've worked on 150 plus projects just within the last 10-15 years. Everything that I have designed is designed for manufacturability, which is pretty rare actually now. I've worked with about 50 different companies, tiny little one-person startups you've never heard of, to manufacturing giants like Chrysler and Intel, NASA, companies like Spalding. So the last couple seconds of this video, I'd like to rattle through a number of the different projects that I've worked on. Worked on fuel cells, sculpture projects, surgical implant tools, compressor molded parts, high density aerospace connectors, more rocket nozzles, desktop prototyping, desktop 3D rapid prototyping systems, cancer screening medical devices, more surgical tools, hip implant, devices for testing NASA, rocket nozzles, satellite hardware that's in space today for the Navy, and satellite hardware that's about to launch in about 6 months. I've done a ton of stuff. Worked with a lot of really great engineers and a lot of really innovative companies. But the real key is designing stuff to be made. Because if it doesn't go to production, what's the point? Everything I've talked about in this video has gone into production, something that I'm very proud of. And it's probably less than 1/10 of the types of projects and products that I've actually worked on. If there's anything that I'm competitive about, anything that I'm compassionate about, is getting products into production. And that's why I think that I should be your top engineer. My wife suggested that I say crikey a lot, so there you have it. Some of you are probably wondering what this is. I was a freshman in college, and I had a CNC class. And this is the very first CNC part I've ever made. Biff was the name of the air band I was in college. Played bass guitar, as if it really mattered.